Hello everyone, this question requires us to prove by induction that summation of 3 to the power r minus 1 from r is equal to 1 up to n, everything is equal to 3 raised to the power n minus 1, everything divided by 2. Now to achieve this, we are going to use a step where t is testing for the validity, A is for assumption, then P is for the proof, and then E is for conclusion or explanation. So step number 1, let us test for the validity of the formula for n is equal to 1. Now we are going to begin from the left hand side, okay? So, and this is equal to summation from r is equal to 1. Remember the value of n, we say that it is 1 of 3r minus 1. Okay, so this is equal to, where there is r, we are going to substitute a 1. So when we do it, we shall have a 3 or 1 minus a 1. But 1 minus 1, that is a 0. So we shall have 3 to the power 0, and any number to power 0, the result is always equal to 1. Okay, now on the right hand side, this is equal to, where there is n, we are going to substitute 1, and when we do it, we shall have a 3 to power 1 minus 1, everything divided by a 2. So 3 to power 1, that is a 3. 3 minus 1, we get a 2 by a 2. And 2 by 2, the result is equal to a 1. Now we are going to compare the left hand side to the right hand side. And when we look at these two, they are all what? Equal. Therefore, we are going to say that the formula is valid for n is equal to 1. Why? Since left hand side is equal to right hand side. Okay, now we are going to do the same for n is equal to a 2, and for n is equal to 2, left hand side is equal to summation. We are moving from r is equal to 1 up to 2 of 3 r minus a 1. So this is equal to, we are going to get r is equal to 1, we substitute it there, and when we did that, we obtain the result as a 1. Okay, then plus, for n is equal to 2, we get this 2, we substitute where there is r, and we shall have 2 minus 1, that is a 1, 3 to the power 1, that is a 3. And this is equal to 1 plus 3, the result is a 4. Now on the right hand side, we shall have 3, where there is n, we substitute a 2, minus 1, everything divided by a 2. 3 squared, the result is 9, minus 1, everything divided by a 2. But 9 minus 1, that is 8. 8 divided by 2, the result is a 4. And when we compare the left hand side and the right hand side for n is equal to 2, it is clear that they are equal. So when we see this happening, we are going to say that the formula is valid for n is equal to 2, since left hand side is equal to right hand side. Okay, and after doing that, we are going to assume the validity of the formula. That is step number 2. So step number 2, we are going to say, assume the formula is valid for the value of n when is equal to a k. So on the left hand side, we shall have summation from r is equal to 1 up to k of 3 r minus 1. And when we try to simplify this, we shall have, we get a 1, we substitute there is r, so we shall have 1 minus 1, that is a 0, 3 to the power 0, the result is a 1. Then plus, where there is r, we substitute a 2, so we shall have 2 minus 1, that is a 1, and then we shall have a 3. Then plus, dot, 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 plus. Remember, we are moving from r is equal to 1 up to a k. So where there is r, we are going to substitute a k. So we shall have 3 to the power k minus a 1. On the right hand side, we are going to substitute a k where there is n. So we shall have 3 to the power k minus 1, everything divided by a 2. So after doing that, we are going to prove. So we prove that if the formula is valid for n is equal to k, comma, then it must be valid for n is equal to a k plus a 1. So we add one step onto this value of k to get a k plus a 1. Therefore, we are going to have a 1, then plus a 3 plus dot dot dot, then plus. Now for n is equal to k plus 1, this ceases to be the last term. So we are going to say this is 3 to the power k minus 1, then plus. Now the last term is going to be, we get a k plus 1, we substitute where there is r. So that is a 3, a k plus 1, then minus 1, everything is equal to, where there is n, we substitute k plus 1 on the right hand side. And when we do it, we shall have a 3, k plus 1, minus 1, everything divided by a 2. Okay. Now, when we try to look at the left hand side of the equation, it is clear that 1 plus 3 plus dot dot plus 3 to the power k minus 1 is the same as this guy. Okay. So where there is 1 plus 3 plus dot dot plus 3 raised to the power k minus 1, we are going to substitute a 3 to the power k minus 1, everything divided by a 2. So this is 3k minus 1, everything divided by 2, then plus k plus 1 minus 1, this gives us a 3 to the power k, everything is equal to a 3, k plus 1 minus 1, everything divided by a 2. So now we are going to prove that this left hand side is equal to the right hand side. So to reach there, I'm going to make sure that the left hand side has the common what? Denominator. So how am I going to do it? I'm going to multiply by 2, then I divide by a 2. And when I do that, I'm going to have my left hand side as the denominator is 2. So here I have a 3 to the power k minus 1, then plus a 2 times 3 to the power a k. And it is clear that we have a 1 times a 3 to the power k and a 2 times a 3 to the power k. What does that mean? I'm going to add the like terms. So I'm going to add just the coefficients, okay? And 1 plus 2, that is a 3 times a 3 to the power k minus 1, everything is divided by a 2. Sorry, this is a 3. But now, when we look closely, we have a 3 to the power 1 and a 3 to the power a k. And when we see this in indices, we say numbers of the same base, we just add the what? The powers. So when we do it, we shall have 3 to the power k plus 1 minus a 1. Everything is divided by a 2. But now, students, when we compare the right hand side to the left hand side, it is clear that they are the same. And when we see this happening, we said that we shall say, hence, the formula is valid for positive integral values of what? Of n. Thank you for watching. Don't forget to subscribe, like and share the video for more about math.